All right. Good morning, good afternoon, good evening, everyone. Thank you for joining us for a partner webinar series talk today with migrating from on-premise NAS storage to cloud NAS storage with SoftNAS. My name is Kyle Lichtenberg. I'm a partner solutions architect here with Amazon Web Services. And today we're going to be joined by a couple special guests, Mark Bickelmeyer from SoftNAS, who's their principal solutions architect, and Chuck Outcalt, the technical project manager from Recomind. Couple housekeeping pieces before we move into the actual content. Submit your Q&A throughout the presentations and throughout the discussion using the Q&A tool that's built into the Connect platform. And also at the end of the webinar, you're all going to receive links with the recording of today's webinar, as well as the links to the YouTube channel where you can find that. And the deck for today's webinar will also be posted on SlideShare, and we'll send off a link for that as well. So today, we're going to cover a few different things. First, I'm going to take you through a quick discussion of how storage works on AWS, how we look at storage, how we see storage from a block and from an object perspective. Next, we're going to talk with SoftNAS on what their solution brings to the table and how that can be used to help you start migrating from an on-premise solution that's already NAS-based to a cloud-based solution that's going to be a little more durable, a little more highly available, and also give you the features and functions that you're used to from that on-site filer. We're also going to hear from Recomind, who is both a customer of SoftNAS and AWS, and hear their story, see how AWS technology and the partnership with SoftNAS has helped them bring their technical challenges, to a point where they're effectively launching applications, developing applications, and leveraging the cloud in a way that's great for their business. We're also going to have a live demo from SoftNAS, so you can see that this technology will fire up live in production and run fun and exciting workloads. And at the end, we're going to have a Q&A. So please, if you have any questions throughout the presentation, feel free to mash those into the Q&A panel on the side of your browser there, and we'll be happy to talk to you about those at the end. So what are your storage options on AWS? Storage is it's a pretty key component to any application, any application platform. Depending on how you look at the storage, you could be discussing your object storage for things like your graphics, your images, your files. You could be talking about the block type storage, the storage that you're using for writing directly to and reading directly from on the operating system. Or depending on your view on things, you could be talking about databases. Technically, that's a type of storage as well. Just storing keys and values and data sets and tables and pulling those things out as needed and when needed. Since there's so many different types of workloads and so many different types of customers, we have several different types of offerings around storage on AWS specifically to meet those needs. Currently, AWS has over 1 million customers in 190 different countries. The expectation that there's going to be one flavor of storage and one shape and size and piece that's going to fit all of those workloads and all of those customers, that's just unrealistic. So we take it on ourselves to innovate as aggressively as we can and produce as many options as we can for our customers to meet them where they want to be and where they need to be to build out these workloads and to remove some of the technical challenges from their businesses. Little bit of background information before we dive in on those. I want to make sure that everyone's comfortable with these two specific concepts. We're going to leave databases off the table for right now, just since that's a different philosophy around storage. And we're going to talk about block storage. So when I reference block storage, what I mean is storage that you are being presented to from an operating system. So it's a set of blocks that's unformatted. You can think of it like when you plug in a hard drive on your computer at home, and you see that device pop up and you see that set of blocks. Typically what you do with that is you format it and you put a filing system on top of it to turn that into something that's useful for you. EBS is our offering with AWS, or it's Elastic Block Storage, that will present network-backed blocks to your server. So you can see these on a single server, you can format them how you like, you can encrypt them how you like, you can use them how you like, just like if you were attaching a normal hard drive to your computer in the data center or even at your home. It's typically used for primary storage for the operating system, for the data, for local databases, those types of things that are running on that server. It gives you very granular control over how that data is stored, where that data is stored, and puts you in a position where you not only have more control over these things, but also need to have more understanding over these things to effectively leverage them. These drives, these block storage devices, can be aggregated into logical arrays using your favorite RAID management utility, LVM or MD-ADM in Linux. Dispart, whichever one's going to be the right fit for your operating system, to create higher performance or higher durability drives and storage systems directly on the system itself. Object storage is a little bit of an abstraction. So what's an object anyway? An object's essentially a blob, a binary large object, or a file. Could be a multimedia file, could be a picture, could be a piece of music, could just be a string of text that you've encapsulated in a specific file type. The object or file is stored in an object storage system using a level of abstraction. So typically there's a file system on top of the blocks, if you want to think about it that way. Or this could be over a network using something like CIFS or NFS. Or this could be using our, something like our S3 service, which is also an object store, and it is remote over the network, and it talks over HTTPS. So the operating system itself knows how to communicate with this storage, but it doesn't necessarily have to directly manage this storage. It's useful for things like log files, cold storage, backup archives, video files, text files, PDF files, any types of files that you want to store or any type of object you want to reference as a complete thing. So as opposed to going to your disk and saying, give me blocks number 6 through 10, you say, give me that picture that matches this key, and this block, the object storage system, will return that type of object to you. On AWS, S3, Simple Storage Service, is our primary object store. It's designed for global scale. It's designed for storage for the internet. You can put a file into S3 and it will return to you a URL. You can decide who can access it, when they can access it, where they can access it from. It's highly durable. It's designed for 11 nines of durability. It's designed for very high availability. And using parallelization, you can get very high throughput from the S3 storage system. However, it is basic in its interface. It is designed to be a store this file and then return this file to me when I ask for it again type scenario. This is fantastic for new applications, for applications that are being developed with modern frameworks and modern systems. If you have some legacy applications, chances are you're not going to be just plugging S3 in as the backend storage type, or if you have existing enterprise applications that just weren't designed for this type of system yet and aren't set to scale in this manner, S3 might be a little bit of a challenge for you to get up and running with. It's priced on a very cloud-centric model where you pay for what you use. If you put a meg of data in there, you pay for a meg of data. If you take that data out, you stop paying for it. This is a little bit different from EBS, our Elastic Block Storage. Elastic Block Storage is our network-based storage system that will present raw blocks like hard drives to your servers. When they're presented to your server, that data is actually being stored in a durable manner off of that instance. But once you have those blocks, you need to format it. You need to set it up in a way that will make it usable by your system, whether it's building an array out of those disks or using it as a single disk. It does give you some great functionality around snapshotting as a backup methodology and some useful features around cloning and moving that data around. But it still takes a level of management from you as the user to make sure you have the right types of disks, the right performance of disks, the right array of storage available to those systems that are going to use them. Related to EBS, in the sense that it's still block storage, are the local instance stores. So when you look at the instance list and you go to start an instance on AWS, you'll see that sometimes they have storage associated with them. That's what we call instance store. The thing that you need to know about instance storage, it is physically attached to that instance. So it is the drive that is inside of that computer, or one of the drives that's inside of that computer, since there's going to be multiple in all of these instance types. When you stop that instance and you start it somewhere else, those drives do not move with it. So the data that you store on the local instance store will go away. It's important when using the local instance store, which is very low latency and in most cases very highly performant and can be set up in a fairly durable manner. It's important to have a strategy for backing that up if it's data that you need backed up, or having a highly available option that is another instance in another zone that it's replicating to in case something happens to that underlying hardware and that system stops. There is a lot of magic associated with the cloud, and the underlying concepts can be a bit confusing, but when it comes down to it, it's computers. It's physical pieces of hardware, and physical hardware from time to time will fail, especially when you start getting to large percentages of scale and the number of systems that are in management under AWS. There's a fairly high chance that day by day, systems will start to go offline, drives will stop functioning. We take great extents and do large amounts of maintenance and management to make sure that these are not customer impacting events, but it's something you need to plan for. Our CTO, Werner Vogels, is quoted as saying, everything fails all the time. So you need to be aware that when you're setting up systems and you're looking at your storage, you need to have a plan in place to make sure that that data is going to be backed up, it's going to be durable, it's going to be available, and it's going to be presented to your systems in a way that is effective for it. These three types of storage on AWS are typically combined to build a type of hierarchy. So there will be types of storage or systems and types of interfaces that will want that very low latency, local instance storage. It's a great option for NoSQL databases, for anything that's going to be very high I/O. It's great to have those things directly attached. The EBS is also great in that area. You can identify the amount of performance that you want from those drives, and it's pay for performance on there. So if you want a very highly performant drive, it's going to cost you a little bit more. But if you don't need a very highly performant drive, then we're not going to upcharge you for something you're not going to be using. Combining those two things together and creating a caching type system is something that one of our partners in particular, SoftNAS, has done very well, and using S3 as a backing store, both for the cloud volumes as well as for durability of those volumes and configuration systems, gives the customers, or gives you as the customer, the opportunity to expand the offerings that we have to enhance and tell a more complete story by offering up things like shared volumes across multiple systems and iSCSI termination for those volumes, and put you more in a conversation around extending your existing systems and developing systems in a way that are going to be conducive to leveraging cloud technology without needing to eat all of the overhead of rewriting and learning how to start doing this right up front. So to talk a little bit more about SoftNAS and how to start your workloads from your on-premise systems into the cloud, I'm going to hand you over to Mark Bickelmeyer, Principal Solutions Architect with SoftNAS.
Thank you, Kyle. I appreciate everybody attending today, and hopefully this will be very informative for you. Tell you a little bit about SoftNAS. The background behind the company is that storage traditionally is kind of difficult to provision, utilize. And the idea is that storage should be able to be very, very powerful in your storage device, as well as easy to use or frictionless. And when the AWS cloud came along, it's kind of reinventing how IT infrastructure is delivered. And when that happened, it kind of, in a way, took a little bit of a step back, and we had to rethink how things were working. So the idea of having a shared storage device in the AWS cloud is as important as having a shared storage device on site. So you get the economies of scale, the idea of combining storage to one device instead of adding storage to each individual server that you're running. In order to offer that in the cloud, we thought, hey, let's build something from the ground up that's made for the AWS cloud that gives enterprises the legacy functionality that they're used to so that they can migrate their applications and their services to the AWS cloud with minimal effort to begin with. So we've built the SoftNAS cloud product from the ground up for AWS. If you notice on this slide right here, there's several brands out there that you most likely have touched on a daily basis, some on a daily basis, others here and there. We have several customer references that use our product, and I don't need to read all of these off, but we have one today in Recommind that's going to talk to you about their deployment. So what does SoftNAS on AWS actually do? SoftNAS provides a unified storage access or device, and it will give you the access to that storage via NFS, CIFS, or iSCSI. Behind this, we can attach to EBS disks and S3 disks. So give us tremendous flexibility in how we utilize the backend storage infrastructure in AWS to provide you with services that you're used to from shared storage devices. So we provide that backend for a shared file system for websites and web applications. We also can take legacy Windows applications that expect a UNC path or a file share to write to and migrate those almost in a lift and shift manner. So pick it up and move it exactly like it is to the AWS cloud. Also, Linux applications using NFS mount points can also do that as well. We think the 6 main reasons to consider using SoftNAS on the AWS cloud is that we give you a very powerful and full features data storage solution. So the things that you're used to today, compression, deduplication, RAID levels, and data protection, so forth, are built into the product. It's built for the AWS cloud from the ground up. We do provide the best data protection available, and I will dive deeper into that in further slides. We have spent an incredible amount of time working on the performance of the product. So the idea is that when you have a shared storage system, it needs to operate fast, and it needs to be performance tuned for that specific purpose. We also wanted to make it easy. No specialized training to use the tool, very easy UI that you're going to see very soon, and effectively give you 20 minutes to a NAS. So in 20 minutes, you should be able to have a NAS device up and running and a shared filer for your applications to use. We also provide it through the AWS Marketplace. So you could go out today, spin it up, and try the product and have it up in 20 minutes and have file sharing set up in the AWS cloud in a centralized fashion. Just a little bit behind the data protection. We combine both EBS and S3 cloud disk storage. So that's the first level that you get. You get the goodness of all of the encryption and the data durability of these systems in the AWS cloud, and then we can layer on top of that. A couple of ways that we can layer on top of that is we have the snap replicate, which will allow us to replicate data from one instance of SoftNAS to another instance of SoftNAS. And we can actually replicate that data from any cloud or any region to another region to any cloud to your on-premise if you'd like. So if you have a private cloud and have a SoftNAS device running, we can replicate up to the AWS and utilizing the same UI and the same systems. So we consistently have that, as well as snapshots and some automatic snapshot pruning as we go along. We also provide high availability. We have elastic HA technology that can give you 5 nines of reliability across availability zones in Amazon. So this is very important. If you lose an availability zone in a region, we can actually fail over and use another availability zone in that same region, which I'll show you here in the demo. This is the way it looks. If you were to set up just one SoftNAS box, you could look at availability zone 1, and you'll see that we have a SoftNAS instance, we have a controller, and we connect to volumes. We have the ZFS file system underneath, for those that are familiar with it. We aggregate together different disk types, so either S3 or EBS drives, into a pool, and you can provide a volume on top of that and share it via CIFS, NFS, or iSCSI. If we go a step further, we can add a second SoftNAS device in another availability zone, set up replication between the two. So every time that I store a file or data on that first machine in availability zone 1, any blocks that change, I'm going to replicate it to availability zone 2. One thing to note about our file system is we're a copy and write file system, so we only write change blocks. So in essence, all we're going to do is take the changed blocks on a device and replicate them over. So we don't have to keep track of files and the file changes. We just look at the block changes, and that gives us an extreme level of performance. The best way to do this, though, is to see a demo. And before I get into a demo, I want to announce something new that is coming out today. We believe in our product. Our product is rock solid. It's ready for the enterprise. And because we believe in that product, we're able to offer you 5 nines of availability if you deploy SoftNAS with our best practices in a dual availability zone, or in a dual availability zone configuration. So if you set that up and you don't have 5 nines of availability, we will refund you a month's worth of your SoftNAS service fees if you actually lose those instances. Please get in touch with us if you'd like more details on this, but we're very excited to be able to offer that today. We also, on our support side, if you register your product, we will guarantee you a 1-hour support SLA on the product. So instead of me talking about bullets on a deck, I'd like to show you a demo. Hopefully this will give you a better view of how SoftNAS works and give you some ideas. So flip over to my screen. And share my desktop here. I've configured 2 SoftNAS devices. I've actually gone out to the marketplace, picked them, and spun them up. Once they've launched, I've logged in through a secure web link to the storage center, and I've gone in and I've started our checklist. So when this machine comes up, it's going to ask you to accept our license agreement, put in an email address for alerting, and soon for registration. And then we're going to say, look, go through this getting started checklist and you'll be up and running. I've already done these first 4 just for time. And I'm going to go to number 5 here, which is add storage devices. Again, for time, I've already added some storage devices to this instance. You'll notice that I've added 2 Amazon EBS disks, as well as an Amazon Cloud disk or S3 disk onto this instance. If I wanted to add additional, or I had no devices attached to this, all I would need to do is click Add a Device. And I can choose either an S3 Cloud Disk Extender device or an EBS disk. If I have an S3 disk, I just click here, I choose what region that I want to put it in, add my keys that I need to add, and create that drive. Oh, let me log back in real quick. And we were in disk devices, so I'm going to go right back to that screen. And I'm going to show you the add device again. So in S3, we can choose our region that we want to go in, and we can choose our maximum file size. Maximum size of the disk. So make that as you'd like, and you'll only get charged for in Amazon for what you actually use. You can also choose disk encryption there if you choose to do that. I can also add an EBS disk, and we've given you all the popular options for EBS. I can choose my EBS type. I can set my provision ops, and I can also choose whether or not I want to delete those volumes on termination. So I already have these disks created. And if I go back to our getting started screen here, I would be able to check off that storage device add. You'll notice in the UI here that when you add storage devices from the UI, we'll already bring them up partitioned. This one right here happens to be the ephemeral drive on the box, and it's not. And I left it that way to show you that if you do attach a disk to this while it's running from the EC2 console, if you hit refresh, the disk will show up here, and it will say it needs a partition. You simply need to just go click this button. It's non-destructive, so you can click partition all, and we'll partition the ones that are not partitioned for you. And you're all set. So we can check partition storage devices. The next thing that we need to do is create a storage pool. As I mentioned before, pools are an aggregation of disks. So I will take the disk that I created already on this machine and create a pool. And I'm going to call this pool Pool 1. I've also decided that while there's plenty of durability built into Amazon, I want to be able to change the tires on the bus if something happens. So there is a possibility you could lose one EBS volume. So I'm going to say I want to go ahead and do a mirror. If I have multiple disks, I'm going to do mirrors and stripes just so that I get the performance of those stripes and the actual data throughput to those. I'm going to click Create, and I have a storage pool. The next thing that we would do is go back and check this off, and we create volumes and LUNs. So if I click on here, it's going to take me to this Volumes and LUNs tab, and I simply need to click Create. To create that volume name, I can name it whatever I want. I do need to pick what storage pool that I put it in, and we'll select the pool. And here I want to decide, do I want to, if I want to do an export via system or create an iSCSI LUN. Today I'm going to show you real quick how to create 2 file systems. I'm going to do an export to NFS here. I'm going to then provision this volume so that all of my volumes that I create on this pool can take advantage of the pool size. So if I expand it, I'll be able to take advantage of an expanded pool without having to resize my volumes. You notice we do have compression and deduplication built in. This is where you would check these things. I'm going to go ahead and turn both of those on, and I'm going to create that volume. So now I have a volume created in that pool. Let's go ahead and also make a SIFS share. I'm going to name this vol2. I'm going to choose that same storage pool, and I'm going to export via SIFS. Go ahead and turn on compression and deduplication. And I have those there. All right, so if I go back to getting started, I can go ahead and check this off. Notice that we have share volumes here. Well, we've done the heavy lifting for you. in that when you created it and you make that check box, we'll go ahead and create the volumes for you. So we created a CIF share that is actually in this path. And if you were to go to this IP address and vol2, you would be in that CIF share. We also, when I chose an NFX export before, we've created an NFS export to volume 1. So we're all set. You're up and running in a single node NAS at this point in time. Both of those exports are wide open. If you'd like to add security, you can through our console here. And if you're a Windows user, we'll allow you to do Active Directory integration. And Active Directory integration is simple as doing a click-through 5-screen wizard. You give the information about your domain, a few passwords, and you're off and running. Once we are integrated, we do support advanced permissions on top of Active Directory. So if you get very granular about the rights that you assign in Active Directory, we will support those on SoftNAS. All right, I'm going to go back to my Getting Started tab. I've shared the volumes. Then we have this number 10, and 10 is next steps. So there's some things that you can do to continue to configure and tune SoftNAS. But one thing I want to focus on is our replication technology. If you notice, while this is loading, I've gone ahead and done a little bit of prep over here, and I'm just going to refresh so it doesn't time out on us. And I've already done some configurations. If you notice that here I have created a storage pool. That's the only thing I've done on this side. I've created a storage pool with that pool name. I also have volumes. If I go down to disk devices, you'll notice that I have 2 disk devices here that are 10 gigs, but I've only put one into pool 1 because I've decided this is a secondary and I don't need to eat up all the storage and duplicate it to both. So I'm able to create a same pool name with the same size volume, but I'm using half the storage on my target device. In order to set up replication, it's very easy. As long as I have this second node set up, all I need to do is go add replication. I'm going to click next. I just need to know the IP address, the target IP address of that machine, and that happens to be my private IP address of the target. I'm going to click next. I'm going to give it the password of that target node. Put that in. And I'm going to click finish. We're pretty fast about setting up replication. So we're actually launching, we're setting up some key pairs, and we're doing a first replication. Let me show you a couple settings before we go over and look at the other box. You can actually set a throttle. By default, our throttle is enabled. If you have a large workload that you're testing, if you go try this out, go ahead and unclick that throttle unless you really need to control the bandwidth. By unclicking that throttle will allow full bandwidth from machine to machine, and you'll see replication happen as fast as we can. Once that initial sync is done, feel free to turn the throttle back on or change how you want to do that. I'm going to go ahead and click cancel there. I now have replication set up. If I go over to this other device, as we looked before, we didn't have any volumes. If I click refresh, you'll notice that we already have those volumes over. So we take the whole configuration of this box in this pool and actually move it over to this SoftNAS box. All you have to do again is have this SoftNAS box up with the same pool name, and we'll take care of the rest. So the next step is to add actually that high availability feature. And if I've set up a lot of high availability in my life, and it's hardly easy. And I'm going to show you probably the easiest way that I've ever seen and the fastest to set up high availability. So I need to put in my virtual IP address that I'm going to use. I don't have that memorized, and I will go back and do this real quick in just a second. But the next screen will actually ask for some keys. We can support IAM roles. However, when I set up this box, I didn't set up the IAM roles, so I have to put in some keys. So if you'll bear with me for just 1 second, I'm going to pause screen sharing so that I can put my keys in. in a safe manner, and then I'll be right back with the share. And we'll come back to the screen sharing. Thank you for bearing with me for that little pause. You'll notice I've put my keys in, and now we're going to click Finish on Setup. We will do all the heavy lifting in the background and get it set up, make sure that all the prerequisites are met, and run through the setup. And it just takes a little bit of time calling the APIs that we need to call, talking to the other box, make sure it's working. I think I saw a question flow in about our replication. Our replication is not synchronous. I'm sorry, not synchronous, it's asynchronous. We work in an active passive mode. So your source node is active, your target node is in a passive read-only mode. So we will not push changes back, and we'll keep the target node in sync with the source node. All right, so we have the replication. The replication is complete, and HA has been added. So I think that took under a minute to configure HA when we got replication going. And if you have a prerequisite set up, it's very fast. And you should be 0 to NAS in 20 minutes and 0 to HA in 30 at the absolute maximum if everything is set up. So I'm going to flip back to our slides now. If I get the Adobe Connect, we will flip back to the slides and tell you about his deployment as now that's going. Also, before I go that, today, if you'd like to try the product, you can go to this link. It will be provided here and at the end of the presentation. If you go to this link, we'll direct you to the marketplace where you can have a free 30-day trial of SoftNAS and try this yourself on your own. Compute and storage charges are not included in that free trial, but the use of the SoftNAS software is. And Chuck, I'll let you take it over.
All right, thanks, Mark. As you can see, I'm Chuck Alcout, and I'm a technical project manager that works for Recommind Incorporated. We're located in San Francisco, California. Recommind has locations in the United States, Canada, Australia, Germany, and the UK. The main business is e-discovery. Our main application is the highly regarded Accelerate 5 NG, which is built on Recommind's core platform. Today I'd like to take a moment to speak on a few topics that I've had experience with utilizing SoftNAS to help Recommind reach its goals. First thing I'd like to talk about is requirements that Recommind had to even start thinking about moving to the cloud from the standard brick and mortar type of data center that we're at right now. I'd also like to speak on a system we have set up right now to archive inactive Accelerate NG products, applications, from costly storage to cheaper storage that's provided through SoftNAS at AWS. And finally, I'd like to speak a little bit more about the process we went through in choosing SoftNAS as our vendor of choice. The Accelerate application houses a lot of data. The data starts basically with delivered to us by the customer. This can be anywhere, any type of size. One SaaS customer that we have currently has less than a terabyte. Other customers that we're talking to are far in excess of 100 terabytes or more. Accelerate then will take that data and crawl it, pulls all the PDFs, docs, attachments, and saves them off to the side and creates an index. The index and natives can basically expand that data almost twofold. All this data compromises one project in Accelerate. As in many applications, things get used, and then the usage drops after the use is no longer needed. Things end up staying on disk for long periods of time, even though they're very inactive. Currently, we're paying roughly 12 cents a gigabyte for that storage. I believe the storage costs at Amazon are a bit lower than that. I'm planning on paying less than 3 cents a gigabyte. So where does it make sense to store this data? Of course, in S3. Recommind needed a solution to archive these applications to cheaper storage, and SoftNAS was there with the answer. One solution that SoftNAS product that was talked about earlier is the ability to create S3 cloud disks. The product will create a bucket in S3. This bucket is added to a storage pool, and then you can present that bucket as a CIFS share, NFS, or in our case, we're going to be using iSCSI for the transport. So it's pretty obvious where we need to store this data. We get the super durability of S3, accessible how we want it to be. And here's a diagram basically to visualize that archiving application. The left side is current brick and mortar data center where we have all of our application servers, etc., set up right now. We've set up a VPN tunnel between the data center and our VPC that we have set up at Amazon right now. We have a SoftNAS instance located within that VPC at Amazon. Right now we're using an M3.X large instance, which is 4 cores and 15 gigabytes of RAM. When we first started looking at storage solutions, the requirement was basically to set up NAS at Amazon like we have at our current brick and mortar. I like to find at least 3 options when I'm investigating possible solutions for the company. Anyone who's looked at options knows that there are free or nearly free options out there. Recommind is largely a Windows shop and has limited Linux resources, so we would have needed to build that expertise in-house. In testing, I also saw slower speeds, read speeds, and what Recommind is largely interested in is that, read speeds. There are extremely limited support options, short of supporting it yourself and Googling your way to success. Another vendor that we were looking at basically attempted to have their systems located geographically close to any of the Amazon data centers. And they actually have 2 sites that are apparently located right next door to Amazon's website or data centers, and they're connected via 10 gigabyte line. You can actually dedicate physical drives to your EC2 instances. We saw slightly better write speeds with that product, but much slower read than we saw with SoftNAS. And the storage costs here were actually paid to the vendor, not Amazon Web Services. So you're not paying the AWS price for storage, which brought on a higher cost. So of course our third option was SoftNAS. The setup was, just as Mark mentioned, simple. Configuration and flexibility it provided was incredible. If I don't necessarily need ultra performance, the S3 Cloud disk is really the best thing since sliced bread, in my opinion. I can easily have that accessible any number of ways. Well, not any number, but iSCSI, NFS, or CIFS. If I need faster performance, I get that by putting EBS volumes into a single storage pool. And based on what my need is, I can configure that as, striped, RAID 5, any one of the RAID offerings that everyone's well aware of. With the thin provisioning, we can save money there since we're only paying typically for what we use. It also provides the performance and highly available options that Mark also just went over, allows us to connect to the data in multiple ways. With all of this, the choice for us was pretty easy. SoftNAS was our vendor, at least for storage solutions at Amazon. I think Mark, come up.
I am. So we actually got through the content we actually got through the content pretty quickly, and we wanted to do that on purpose so we'd leave plenty of time for question and answer. I'd like to thank you all for joining us today, number one. Number two, I'd like to thank Kyle for the great background and storage on AWS. And most importantly, I really would like to thank Chuck for joining us today and sharing his use case. I hope it's been very valuable for you. The next step that we're going to do is encourage you to go out and try SoftNAS. What I didn't show on the slide before is that we have a free SoftNAS trial, and if you spin it up on a micro instance, you could actually run that as long as you want from a storage perspective on that free micro instance. I will say that micro instances should only be used for small testing and development purposes. That I wouldn't use a micro instance in a production deployment. You can learn more, softnas.com/AWS, and again, using that bit.ly link. So bit.ly softnas-AWS will take you to the page that you need.